Okay, today we start talking about the formulating and applying of the system of a system of equations. So, formulating and applying a system of equations involves writing a set of equations that represents a situation. And applying of a system of equations implies that we're going to implies solving the system of equations and interpreting the solution in context of the situation. So in order to do this, we're going to do 4 steps. Now, not listed in the steps are things you should already know. So back when we wrote equations and we talked about what words represent different computations and things of that nature, that's assumed that you know that at this point. It's assumed that you know how to write an equation. So step 1 is going to be declare the variables. So declare the variables. And of course, usually we're going to use X and Y, but you can use really any 2 letters that you want to. But on the pages, I just used X and Y. So declare the variables. That means you're going to say what each one of them is going to represent in the problem. Step 2 is going to be formulate the system of equations. So when we formulate it, we're going to write a system that can be used to determine the solution. Step 3, solve the system. So when we're solving it, we're going to have to determine the best algebraic method, whether that be substitution or elimination. That we're going to use to solve the equation. And then step 4, interpret solution. So that's us writing a solution sentence in context. Okay, so those are the 4 steps we're going to use. Kind of made an outline for you on the next page. We're going to go over a couple examples. So example 1, the sum of 2 numbers is 28 and their difference is 4. What are the numbers? So declare the variables. So we're going to have x be the first number and y be the second number in terms of formulating. Typically, we want to find out 2 things about both sets. So we know their sum, which means addition, of the 2 numbers is 28. So x plus y equals 28, and their difference is 4. So x minus y equals 4. So I'm going to take my system and decide next when I'm solving it, which do I think is best method to use, substitution or elimination? Well, if I line these up, x and x, y and negative y, I can see I have an additive inverse right there. So I think elimination is going to be the best method. So x plus y equals 28 and x minus y equals 4. Insert line right here. May not be a straight line.
And they're not related. And there's this huge responsibility in making sure that when he's...
My TV came on for a second. Sorry about that. So when I do elimination, I can see that I'm going to be left with 2x. The y's are going to fall out. And 28 plus 4 is 32. Then, of course, I'm going to divide both sides by 2. Leaving me with x equal to 16. So I have eliminated, I've solved, and I'm eliminated. I didn't have to multiply, so I eliminated and I solved, and I got x equals 16. And I'm going to come over here and do the second variable. So I'm just going to do 16 plus y equals 28. So minus 16 from both sides. I'm going to wind up with y equals 12. So at this point, I know that x is 16 and y is 12. That's my solution. So how can I interpret the solution? Well, I know the two numbers whose sum is 28 and difference is 4 are 16 and 12. Okay, so that's the steps that we're going to follow. We're going to go on and do some more challenging problems now. So the next example, it says a lab needs to make 100 gallons of an 18% acid solution by mixing a 12% acid solution with a 20% acid solution. How many gallons of each solution are needed? This should bring you back to when we did weighted averages, and this is another way to do weighted averages where we're going to actually use a system to help us. So declaring the variables, X, I'm just going to pick that it's going to be the 12% acid solution. And Y gets to be then 20% acid solution. And so what do I know? I know two things. I know that they need to make 100 gallons of this, and that the final solution is 18% acid. So in the first one, I'm going to take my X plus my Y, and I should say over here when I declare the variable that this is going to be the number of ounces, or actually number of gallons. Get to my not spell right now. You know what? I'm just going to leave it like that. I'm going to shorten it down. Making it a little smaller. So you can do that as well. So I had to go down to a 22 and a 23. So together, the number of gallons of 12% and the number of gallons of 20% have to equal 100 gallons. Then I also know the number of 12%, so 0.12x, plus the number of 20% must equal 18% solution. You'll notice I changed those percentages to decimals by moving the decimal over 2 decimal places to the left. So in looking at this, I don't really see anything that's going to match up easily for elimination, but I could easily convert this in and isolate one variable and solve. So currently I have x plus y equals 100 and 0.12x plus 0.20y equals, let's go ahead and multiply 100 by, well, actually I put it in there by now. I'll put it in here as it is now. So 0.18 times 100. So I can change these to be x equal, and I'm just going to put 100 minus y. So I isolated that x by moving the y over to the other side by subtracting it. And then 0.12x, that was my first step, isolation. Now I'm going to go ahead and substitute this in. So I have 0.12 times 100 minus y plus 0.2y, 0.20y equals, and 100 times 0.18 is going to be 18. So I'm going to go ahead and distribute. So 12, 100 times 0.12 is 12, minus 0.12y plus 0.20y equals 18. I'm going to combine to get 12 plus 0.08y equals 18. I continue on over here. I can take and subtract the 12 from both sides. To get 0.08 y equals 18. So 18 divided by 0.08 is going to give us 125. That seems off. Oh, here we go, right here. Hello. That should be 6. So 6 divided by 0.08 is going to be 75. See, little math matters when you're working late like Miss Egan is. Doesn't help. I think we're going to need more space. So I'm going to come over here and I'm just going to change this to a size 18. I'm going to change this to a size 18. I'm going to have to go a little bit smaller than that, I guess. Bring it over. 14, I guess. Okay. Okay, so now I know y equals 75, so I'm going to substitute that back into the x plus y equals 100. So x plus 75 equals 100. I think we could all see that x would have to equal 25 gallons. Therefore, we have a solution of 25 and 75. Interpreting that, we should know x is the 12% solution and y is the 20% solution. So come down here. In order to make the 18% solution, 25 gallons of the 12% solution and 75 gallons of the 20% solution will be needed. Moving a little slow here. Not my misspellings here. So that's the second one, a challenging one where we have to think about how, like, not only the number of ounces, but anything that might go along with them. Okay, the third example says, moving slow. English is spoken as the first language in 78 more countries than Farsi. Together, English and Farsi are spoken as the first language in 130 countries. In how many countries is English the first language versus the number that Farsi is the first language? So we're going to kind of shorthand this. Number, countries, English. Number, countries, Farsi. And then based on what we know that together, so together would be adding, so we're just going to add those, x plus y equals 130 countries. So English plus Farsi will give us 130. And then English is spoken as the first language in 78 more countries than Farsi. So in our head, we could say that we would have English, which is our x, equal to Farsi, which is y, plus 78. But if I bring that y over, English, number of English-speaking countries minus the number of Farsi-speaking countries must equal 78. You can see we're going to have some elimination here. So we have x plus y equals 130, and x minus y equals 78. The x's will drop out, leaving us with 2x equals 208 countries. So if we divide both of those by 2, we'll get x equal to 104. So now we can just bring that over. We would have 104 plus y equals 130. So subtract 104 And we get y equals 26. So we can say there are 104 countries where English is the first language, while 26 countries have Farsi as their first language. One outside the box. Of course, I didn't spell language right because it's kind of late at night. Okay, so those are 3 examples, and then we're going to do example 4 in class because it's a little bit more detailed to talk about. We're going to relate that back to distance equals rate times time. And then there's several GPs that you have to do that are very similar to this, and one that is matching. And that is formulating and applying system of equations.